Welcome to the fascinating world of blockchain technology. Here we will explore the intricate workings of blockchain networks, focusing on their core elements, decentralization and architecture. Let's uncover the fundamentals behind this groundbreaking technology, reshaping industries and redefining trust and security. In understanding blockchain networks, decentralization, and architecture, we will cover five important parts. 1. Blockchain basics. We start from the ground up, explaining how blockchain works. Number 2. Decentralized nature. We will see why being decentralized matters so much in blockchain. 3. Decentralized architecture in blockchain networks. This part explores how the system is structured in a decentralized way. 4. Peer-to-peer communication in blockchain networks. We explore how the different parts of the system talk to each other. The last one, summary. Finally, we will sum up everything we have learned in a nutshell. Okay, let's start with the fundamental components of a blockchain. First of all, let's see what is blockchain. Blockchain is a distributed ledger technology that stores records of transactions across a network of computers. Digital ledger. So it is a digital record keeping system where data is stored in blocks linked together in a chain. Each block contains information such as transactions, timestamps, and a unique identifier hash. Let's start with the basics of blockchain. Think of it as a fancy digital notebook. It stores data in blocks linked together like a chain. Each block holds stuff like transactions, timestamps, and a special code called a hash. It is like building a storybook with each block holding important information, all linked up in a chain. Okay. Block structure. Each block stores a certain amount of data. When filled, it is cryptographically linked to the previous block, forming a chain. This link is established through the hash of the previous block, ensuring the integrity of the entire chain. Moreover, blockchain operates like a digital chain of blocks securely storing various data, such as transactions and timestamps. Each block is meticulously linked using codes, ensuring not only security but also seamless continuity. Think of it as a highly secure digital ledger, effectively keeping everything intricately connected and superbly organized. Okay. Decentralization. This decentralized nature means there is no central authority overseeing the blockchain network. Instead, it is maintained by a distributed network of computers nodes. Each node holds a copy of the entire blockchain and participates in validating and adding new blocks to the chain. Alright, let's talk about decentralization. It is like having no boss overseeing everything in a blockchain network. Instead, there are lots of computers called nodes spread out everywhere. Each of these nodes has a complete copy of the whole blockchain and works together to check and add new information to the chain. Okay. Figure 1 displays 3 blocks. Each block contains transaction data, transaction 0, transaction 1, transaction 2. Timestamps indicate when each block was created. Pre-hash shows the reference to the previous block's hash. Hash represents the hash of each block, including data and the previous block's hash. Let's take a look at figure 1 showing a typical blockchain. You will see 3 blocks: block 0, block 1 and block 2, each holding transaction data like transaction 0, transaction 1 and transaction 2. The timestamps tell us when each block was made. Now notice pre-hash, that is the link to the previous block's unique code, and hash is the code for each block securing its data and the reference to the previous block. In summary, a blockchain's strength lies in its decentralization, secured by cryptographic principles, and its structure, where each block links to the previous one, creating an unbroken, tamper-resistant chain of data. Understanding these fundamentals is essential for grasping how blockchain networks maintain transparency, security, and reliability in various industries. In essence, blockchain's strength lies in its decentralized structure, where each block is linked securely to the previous one, creating an unbreakable chain of data. Understanding these basics unveils how blockchain maintains security and reliability across industries. Stay tuned for more insights into this groundbreaking technology. Okay, now let's explore the heart of blockchain: decentralization. No single authority. Unlike traditional systems where a central entity controls the data, blockchain operates without a single governing body. This absence of centralization distributes power among participants. Actually, in blockchain, there is not one big boss. Unlike traditional systems where a central entity controls everything, here power is spread among all involved. It is like a team effort. No single entity rules the domain, giving everyone a piece of the control. Okay? Consensus mechanisms. Decentralization is maintained through consensus mechanisms like proof of work (POW) or proof of stake (POS). These mechanisms enable nodes to agree on the validity of transactions and the state of the blockchain without relying on a central authority. Now, let's talk about how we keep things running smoothly without that big boss. We use these cool things called consensus mechanisms like proof of work or proof of stake. They are like teamwork champions. Okay? Instead of waiting for a central authority to approve things, these mechanisms help all the computers, that is all nodes, agree on what is legit in the blockchain. That way, transactions stay honest, and the blockchain stays strong without needing that one. Enhanced security. Decentralization increases security by making it difficult for malicious actors to manipulate the system. Altering data in one block would require changing every subsequent block across multiple copies of the blockchain on various nodes, which is extremely challenging. Let's talk about how decentralization increases security. See, in a decentralized system like blockchain, it is really tough for the bad guys to mess things up. Imagine this: if someone tries to change info in one block, they should have to change every single block that comes after it in lots of copies of the blockchain across tons of computers. That makes it super hard for them to pull off any funny business. Okay? Transparency and trust. Transactions on a decentralized blockchain are transparent and immutable. Once recorded, data cannot be easily altered or deleted, cultivating trust among participants. Let's discuss transparency and trust in a decentralized blockchains. When something is logged on this type of blockchain, it is like having it in a bulletproof vault. It cannot be tampered with or erased easily. This transparency ensures that everyone involved can see and trust the recorded information, creating a solid foundation of reliability and trust among all participants. Okay? Overall, blockchain's decentralized nature promotes transparency, security, and resilience by distributing control across the network rather than relying on a central authority. Actually, a blockchain is like a big team where nobody is the boss. It spreads control across everyone, making everything clear, safe, and strong. This way, there is no single authority, just a network working together for transparency, security, and resilience. Okay? Now, let's explore the decentralized architecture in blockchain networks. Decentralized architecture in blockchain networks refers to the structural framework where multiple nodes, computers, or devices work together without a central authority to manage transactions and data. That is, decentralized architecture in blockchain means no central authority. Instead, many nodes collaborate to manage transactions and data. What are the key features of decentralized architecture? Peer-to-peer network, node interaction. Nodes connect directly in a peer-to-peer fashion, allowing them to communicate and share data without a central server. Alright, let's explore how decentralized architecture works in a blockchain networks. Think of it as a big web of connections, like everyone in a giant chat group. In blockchain, these nodes, think of them as team players, talk to each other directly, no middleman needed. This peer-to-peer setup allows them to share info, work together seamlessly, kind of like a digital team collaborating without a boss. Okay? Distributor ledger, shared and replicated data. The ledger blockchain is duplicated across all nodes in the network. Each node maintains its copy, enabling decentralized storage and verification of transactions. That is, the ledger or the record of transactions, that is, blockchain, is like a book every member has. Each node keeps a copy, spreading it across the network. This duplication allows decentralized storage and verification of transactions, like having multiple copies of the same book for accuracy. Okay? Consensus mechanisms. Agreement without central authority. Nodes reach consensus regarding the state of the blockchain and transaction validity through consensus algorithms. This agreement occurs in a decentralized manner, eliminating the need for a central controller. Imagine all the computers in the network as a team. They make decisions together without a central boss. These clever algorithms help them agree on the status of the blockchain and which transactions are valid. It is like a democratic decision-making process where everyone's voice counts, no central controller needed. Okay? Security and immutability. Tamper-resistant design. Blockchain's cryptographic principles ensure that once data is added to the chain, it becomes extremely challenging to alter or manipulate without consensus from the entire network. Alright, so let's talk about security and immutability in decentralized blockchain architecture. Think of blockchain as a vault sealed with super strong codes. Once something is in there, it is really tough to change without everyone's agreement. These cryptographic principles make it extremely hard for anyone to mess with the data once it is added to the chain. It is like a digital lock that keeps everything safe and unchangeable without the network's approval. Okay? Absence of central control. No single point of control. Decentralized networks operate without a central governing entity distributing power and decision making across all participating nodes. This means decentralized networks in blockchain work without a boss. There is no single control point. Power and decisions are shared among all nodes. It is like everyone has a role, making decisions together without relying on one central authority. Okay? We will see here advantages of decentralized architecture in blockchain networks. Enhanced security. Decentralization minimizes the risk of cipher attacks or fraudulent activities due to its distributed and immutable nature. Let's explore the advantages of decentralized architecture, starting with enhanced security. Because decentralized systems spread data across many points and make it unchangeable. It is like having a super shield against cipher attacks or fraud. This setup makes it really tough for bad actors to mess with the system, providing a strong layer of security. Okay? Transparency and trust. Transactions are visible to all participants, cultivating trust through transparency and ensuring that records cannot be altered without consensus. That is, decentralized architecture brings a key benefit: transparency and trust. Here is how. All transactions are open for everyone to see. Okay. This transparency builds trust because records cannot be changed without everyone agreeing. It is like having a transparent system where everyone is on the same page, ensuring reliability and trustworthiness. Okay. Resilience and fault tolerance. Decentralized networks continue to function even if individual nodes fail or experience issues, ensuring continuous operation and data availability. Imagine this: even if a few computers in the network have trouble or stop working, the whole system keeps running along. This setup ensures the network does not break down easily, that data is always available. It is like having a team that keeps playing even if a few players need a break, ensuring the game goes on without interruptions. Okay? Removal of intermediaries. By eliminating intermediaries or central authorities, decentralized architectures streamline processes, reduce costs, and enable direct peer-to-peer interactions. That is, decentralized architecture offers a major benefit: cutting out middlemen. When we remove intermediaries or central authorities, things become more efficient. It is like a shortcut, processes get faster, costs go down. Further and further, we can deal directly with each other. Skipping the middle steps means quicker, cheaper, and more direct interactions. Okay? Decentralized architecture in blockchain networks transforms traditional centralized systems by offering transparency, security, and autonomy while reshaping various industries and applications. So, blockchain's decentralized architecture transforms old centralized systems by bringing transparency, security, and freedom. It is changing industries and applications, offering a whole new way of doing things, offering an entirely new way of doing things. Okay? Here, we will explore the workings of peer-to-peer communication in blockchain networks. Peer-to-peer, P2P communication in blockchain networks refers to the direct interaction between individual nodes, computers or devices within the network without the need for intermediaries or central servers. Peer-to-peer communication in blockchain means nodes talk directly without middlemen or central servers. It is like neighbors chatting over a fence, direct, without anyone in between. Okay? Now, let's explore the characteristics of P2P communication in blockchain. Direct interaction, node to node communication. Nodes within the blockchain network connect directly to each other, enabling the exchange of information, data, and transactions. Let's explore the characteristic of peer-to-peer communication in blockchain. Think of it like this. In a blockchain network, every computer or node talks directly to each other. It is like having a direct line. These nodes connect and share information, data, and transactions without needing any middleman. They are like a big team communicating directly for a smooth exchange of information within the network. Okay? Broadcasting transactions. Transaction propagation. When a transaction is initiated, it is broadcasted across the network. Nodes receive and validate this information, passing it along to other nodes, ensuring that all nodes have the latest transaction data. Let's talk about how transactions spread in blockchain's peer-to-peer communication. It is like this. When someone starts a transaction, it is like sending a message to everyone in a big group chat. These computers or nodes get the info, check if it is legit, and then share it with other nodes. It is like making sure everyone is on the same page so all the nodes have the most up-to-date transaction details. Okay? Verification and consensus. Data validation. Nodes engage in verifying transactions and reaching consensus by sharing and validating information. Through consensus mechanisms, nodes collectively agree on the validity of transactions before they are added to the blockchain. Okay, let's talk about how verification and agreement happen in blockchain's peer-to-peer communication. Think of it like this. All the computers or nodes work together to check if transactions are legit. They do this by sharing and double checking the information. It is like a team effort using consensus mechanisms. They agree on which transactions are valid before adding them to the blockchain. It is a way to make sure everyone is on the same page before recording anything permanently. Okay? Redundancy and resilience. Data replication. Each node maintains a copy of the entire blockchain. This redundancy ensures that if one node goes offline or experiences issues, other nodes still possess the necessary data to maintain the network's functionality. Let's explore the characteristics of peer-to-peer communication in blockchain, focusing on redundancy and resilience. Picture this. Every computer or node has a full copy of the entire blockchain. This redundancy is like having multiple backups. So even if one computer has problems, others still have all the needed data to keep the network running smoothly. It is a safety net ensuring the system stays up and running even if some nodes face issues. Okay? Efficiency and decentralization. Decentralized data distribution. P2P communication facilitates decentralized data distribution, reducing reliance on centralized servers and enabling more efficient and direct interactions among network participants. Okay, let's talk about how peer-to-peer communication in blockchain brings efficiency and decentralization. It is like this. Instead of relying on big central servers, data gets spread out among all the computers or nodes. This setup allows for more direct and efficient interactions between everyone involved. It is like having a streamlined way to share info. No need for a big server, just direct connections among all the network participants. Let's talk about the advantages of P2P communication in blockchain. Enhanced security. P2P communication ensures that data exchanges occur directly between trusted nodes, reducing the vulnerability to to interception or manipulation by third parties. That is, B2B ensures direct and secure data exchanges among trusted nodes, lowering the chances of third party interference or manipulation. Okay? Data integrity and consensus. P2B communication supports the validation of transactions and consensus building among nodes, ensuring the accuracy and integrity of the blockchain data. This means B2B communication backs up transaction validation and consensus among nodes, making sure the blockchain data stays accurate and secure. Okay? Resilience to single point failures. The distributed nature of B2B communication ensures that the failure of individual nodes does not disrupt the entire network's operations, maintaining overall system stability and reliability. Okay, let's talk about why peer-to-peer communication in blockchain is so resilient. P2P P2P's distributed setup means if one node fails, it does not bring down the entire network. This keeps the system stable and reliable, even if pods face issues. Okay? Efficient data propagation. Transactions and data propagate quickly across the network due to direct communication, allowing for rapid validation and consensus building among nodes. That is, P2B speeds up data flow by directly communicating transactions across nodes. This quick exchange helps nodes validate and reach consensus faster. Okay? P2B communication forms the backbone of blockchain networks, enabling direct, secure, and efficient interactions among nodes while upholding the centralized and transparent nature of the technology. So, P2P communication is the core of blockchain networks. It lets nodes interact directly, making it secure, fast, and keeping the whole system decentralized and transparent. Okay? Let me conclude this video with the summary. In essence, blockchain's decentralized architecture promotes transparency, security, and trust by distributing control across a network rather than a central authority. This framework, coupled with peer to peer communication, ensures data integrity, resilience, and efficient interactions. Ultimately, it transforms the industries, offering a secure, transparent, and autonomous platform for diverse applications. Let's sum it up. Blockchain's decentralized setup brings transparency, security, and trust by spreading control across the network instead of having one big boss. This, along with direct peer to peer talk, keeps data solid, the system resilient, and interactions efficient. It is like a game changer for industries, providing a secure, open, and self governing platform for all startup users. It is a whole new way of doing things, making everything safer, clearer, and more independent. Okay?